What if I told you there are things that math says can never happen, but in the real world, they do? Imagine this. A particle exists in two places at once, or a shape that splits into two identical copies of itself with the same volume as the original, or a cat that's both dead and alive on until you check. Sounds insane, right? Welcome to the strange space where mathematics and physical reality collide, and sometimes don't agree. This is not just about nerdy puzzles or abstract equations. This is about the very limits of our universe and whether numbers can fully explain what's out there. Let's dive in. For centuries, math has been praised as the purest language. Clean, logical, eternal. Galileo said, "The universe is written in the language of mathematics." And so far, it's done a pretty good job. We've used math to predict planetary motion, build skyscrapers, decode DNA, and even simulate black holes. But here's the catch. Math is a model, not the reality itself. It's like a map, incredibly useful, but not the terrain. Richard Feynman once said, "Mathematics is not just calculation. It's an attempt to express the laws of nature in a logical system. But sometimes that system doesn't line up perfectly with nature's chaos. And that's where things get weird." Let's start with the juicy one. The Banach-Tarski Paradox is a mind-blowing mathematical idea that says you can take a solid sphere, slice it into a finite number of pieces, and reassemble those pieces into two identical spheres, each the same size as the original. Wait, what? Yes, mathematically, it's proven. Physically, it's absurd. You can't do that with an orange. Try it, and you'll end up with pulp, not extra fruit. Why the gap? Because the paradox relies on non-measurable sets and infinite precision, concepts that exist in math but not in physical reality. Our atoms don't behave like mathematical points, so here we find something mathematically possible but physically impossible. Now let's flip it. Now, what about things that do happen physically but seem mathematically impossible? Enter quantum mechanics, the rebel of modern physics. At the subatomic level, particles don't behave like billiard balls. They exist in superpositions. They're here and there, spinning up and down, existing and not, all at the same time. This isn't just theory. It's been confirmed in experiments again and again. But classical mathematics struggles to model this. Probability waves, complex amplitudes, collapsing states, these aren't intuitive or clean. In fact, Einstein himself called quantum mechanics spooky action at a distance. Here, physics leads and math scrambles to keep up. So in this case, the physical world breaks the expectations of mathematical simplicity. Let's take it a level deeper. Kurt Gödel, a logician from the early 20th century, proved that any sufficiently complex mathematical system contains statements that are true but unprovable within that system. In other words, math has built-in limits. Now apply that to the universe. If we treat the cosmos as a mathematical structure, Gödel is saying there are truths in physics that math will never be able to reach. So what happens if a physically possible event lies in one of those unreachable zones? Mind blown. Explosion. Let's look at a few more cases where math says nah, but the universe says yes. Turbulence in fluid dynamics. We still don't have a complete mathematical model of turbulence, yet it happens in every storm, ocean wave, or shaken soda can. The three-body problem. Mathematically unsolvable in general form, physically observable with moons, planets, and stars. Time travel, in theory. Certain solutions to Einstein's equations allow time loops. Mathematically, they exist. Physically, we're still debating. Chaos theory. Infinitely sensitive systems like weather defy precise prediction. We model them, but the models often break. The real world is messier than the math. Each of these examples reveals mismatches between idealized math and messy reality. What if the issue isn't reality, but our math? Historically, every major physics revolution came with a new math tool. Newton invented calculus. Einstein used Riemannian geometry. Quantum theory brought in linear algebra and probability. So maybe the things that seem impossible just need new math. Maybe quantum gravity or dark energy will require tools we haven't even imagined yet. Maybe we're like cavemen trying to describe Wi-Fi using sticks and dirt. There are two camps here. Platonists. Math is real and eternal. The universe follows its laws. Formalists. Constructivists. Math is a human invention. It's just a tool. Depending on your view, you'll either say reality must obey math or math must adapt to reality. And that debate's still raging. Still. So, can something be mathematically impossible but physically possible? In some ways, yes. The math we have doesn't always fit the universe we observe. And sometimes the universe presents mysteries we can't yet encode in numbers. But that tension between what we can prove and what we can experience is exactly what drives science forward. It's a reminder that certainty is an illusion, and that curiosity, not clarity, is the real engine of discovery. So next time you hear, "That's impossible," like remember, math might say no, but the universe just might say, "Watch this. You made it all the way here." Brain spinning, questioning if time is even real. And you're still not subscribed? Look, this channel isn't just content. It's a mental roller coaster through black holes, brain glitches, and bizarre theories your school never dared to teach. If you're into stuff that blows your mind and makes you say, "Wait, Lasti, what did I just watch?" Then yeah, you belong here. Smash that subscribe button so we can decode the universe together. Or at least get really confused trying. And hit the bell too, because if time is fake, notifications better be real. Let's get lost in the weirdest questions of existence. One rabbit hole at a time.